Hello guys, I hope you're all well. Welcome back to Manala's Arc, especially the grade 10s. Here I have video for you about trigonometric graphs. So in this video, we are going to talk about trig graphs, of course, and I want us to talk about trig in 2Ds. So let me start with graphs. What do we mean by things like trig graphs? Obviously, we are talking about things like the cosine graph. We are talking about things like the sine graph. We are talking about things like the tangent graph, that weird one. That one all of you hate to draw. That if a question ever comes and say draw a tangent graph, the one that is negative, shifted upwards and things like that, that's when you get angry at your teachers. So yeah, that is that. You all know the graphs, right? So this video is not an introduction video. This is a revision video. This is where I get to do previous question papers with you. And then if ever you need me to do an introduction video, please let me know. I'll create time for me to create that video. How nice is that? And then so again, we have trig of 2Ds. With regards to trig of 2Ds, here we have weight problems. Now I know many people who do maths. They hate weight problems. They hate anything that has a paragraph in maths and things like that. But then guys, you have to deal with it. Here it is, word problems. In paper 1, your word problems, you have algebraic problems. Those are your word problems. But here in paper 2, your devil, it's in this detail right there. In trig 2Ds, these are the word problems. And then you have to master these things, guys. But to be honest, there's no danger there. So let's get straight to it. Let me save both of us time. So on the previous video, the very first video that I ever did for the YouTube channel, I made an introduction video that addresses the amount of weight you should expect, especially for your final paper, for things like trig. Trig is very important. It's worth close to half of your question paper when you do paper 2. So for November, you need to have mastered this topic. If ever it chows you now, make sure during these holidays you're going to trick yourself to practice trigonometry every day. Good. So now I don't want to talk about this. We already spoke about this. Go check the very first video. You'll see what it talks about. So now this is my working space when I'll be bringing in questions here. Then we solve them together here. And then this here, I collected the questions. This is the part where I collected questions about trigonometric graphs. And then this is the part where I collected questions about trig in 2Ds. As you see there, I attached also where I got the questions from. This is a Gauteng question paper 2 from 2021 November. See that? Because I realized that with the past videos, I made mistakes of not making people aware where are the questions from. We all set. Now let's start with the very first question. Just jump straight into it. Here we have this one. Let me copy it into the working space. So here we go. Let me move it properly. Let's move it here. I think it's nicer this way. So here you are. I'm going to save both of us time for this video. So when I'm working on this thing, I'm looking at this. Now guys, I want to make all of you aware. People would be like, say, why is this 2 marks? Why is it not 5 marks? Guys, when we say 2 marks, we are saying please spend 2 minutes here. When something is 2 marks, you don't spend 4 minutes there. You spend 2 minutes, you move on. That's all we need. So here we have 6.1. It says write down the values of the biggest mistake now I'm doing. You have to read the question carefully. So the question says in the diagram below, here's the diagram, you have the graphs of f of x. Here is f of x. Let me highlight f of x. It's a sine graph. And then you also have the graph of, what is this one? G of x. So let me highlight the g of x. I hope I didn't affect the visibility for that graph, right? So I have f of x, I have g of x. And then here we have a little domain there from 0 to 360, right? So now, in that case, I know that I have 2 graphs here. One of them is a sine graph, one of them is a cosine graph. My biggest role now is to identify which one is which. So yes, I have a cosine graph, but which one is it? So the cosine graph is the blue one. So remember, according to theory, we said a cosine graph, it either forms an N shape, especially when it's negative, or it forms a U shape when it's positive. Now, any of the graphs here that forms an N or a U shape, it's definitely this one. So I highlight the graph right there. Right there. So it will help you if ever maybe you step into the exam with a small highlighter or a Koki pen or something like that for you to highlight things like this. But then it's not a must, guys. It's not a must. So here's the graph of g of x right there. Let me remove the other part. It's terrible. Right there. So here's the graph of g of x. This graph is the graph of g of x. Whatever g of x is. Alright. And then we know that the sine graph obviously has to be the other one. If this is the g of x, the sine graph is the other one. Right? So now, no need for us to solve that one further. We know that this is the graph of f. Even better. They annotated these things for us. I'm wasting time. So now, they need us to find a. Where do we see a? A is in the sign. So whenever you have the following graphs, whenever you have f of x is equals to a multiplied by the sine of x, this function that you see, it has a coefficient, and the coefficient is a. That coefficient always represents the amplitude for a sine graph. It always represents the amplitude, and the amplitude has a formula. How do we find the amplitude? The amplitude is equals to half of the maximum value minus the minimum value. We all see that? Easy as that. Now let's continue to solve for the amplitude there. So we are saying it's half of what is the maximum value for the sine graph. Which one is the sine graph? The f graph. The maximum value is right there. What is the y value there? It's 2. So the maximum value is 2 minus the minimum value. So for this f graph, the minimum value is definitely here. That is the lowest point, right? What is the y value there? It's negative 2. So we are going to say 2 minus negative 2. So let's put it in brackets so it makes sense. And then I close it off with the square bracket. To solve this thing, it's easy maths. We know that 2 minus minus 2, it's 4. And then half of 4, we know that it's 2. So whatever they are looking for there, the value of a, it's 2. Bear in mind again, guys, the coefficient of a represents the amplitude at all times. Now let's move on. Now we are looking for b. Now when we are talking about b, just like the sine graph, b, it's the coefficient of the cosine graph. So here I have the cosine, which is g of x, is equals to b cos x. The coefficient of that cosine represents the amplitude of the cosine, the amplitude. Now, using the same formula now, half of max minus the minimum, I'm going to get the amplitude of the cosine. Now, to proceed with that, I have 1 over 2. It's equals to, what is the maximum value for the cosine? I see that the cosine starts here at 1. It goes down up until this point. At this point, it's negative 1. It goes up again to its highest point, which is 1, right? So now, which means now the highest point, it's 1, because the highest point it ever reached was 1. Minus, what is the lowest point? The lowest point here, it's negative 1. So minus negative 1, in that sense. Now I have 1 over 2 of what is 1 minus minus 1, that is 2. What is half of 2? That is 1. So which means b is 1. Easy as that. That is what I would like to see, guys. So removing that, you found answers for number 1 and for 6.1 as a whole. Easy 2 marks for us there. The examiner will just move on like this. 2 marks for you. Now next one, what we have, this question for 6.2, it says, for which value or values of x will g be decreasing? Now in this one also, it shouldn't be a problem. Let me show you quick. Chop chop. Now we look for the graph of G. We said, what is the graph of G? Here is the graph of G. It's indicated for us, right? We need to know, where is the graph going down? At which point is the graph going down? So for us there, so here, whenever they're asking you for which values of x will G be a decreasing function, what we want you to do is that you look at the graph of G. Here's the graph of G, as we said. You look at the point where the graph is going down. So starting from here, the graph is at rest, right? And then here also the graph is at rest. It's at its turning point, right? So now, how we're going to do that is that we're going to say, since this is the turning point, right there, and this is the turning point, the graph from here, it's going down. It's flowing downwards, 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 up until there, it reaches the turning point. From this turning point now, there, it's going upwards. It's not going down. So the only time where it's going down, it's from here up until there. Now, you mentioned the x values for that. You're just going to say, whenever x is bigger than 0, the graph is going down. Up until when? Up until x reaches 180 degrees. We all see that. Not at 180 degrees. So you don't put the inclusion sign. No. You just say up until 180 degrees. This is one way to do it. Or you might say, when x is an element of, we make curve brackets because it doesn't include the value. 0 degrees and 180 degrees, curved bracket again. That's also another way to do it, right? You don't write the two solutions. You write either or, of either this one or this one. So easy as that. Now 6.3, quick, we have the following. It says, what is the amplitude of f? Now in 6.1 we already spoke about the amplitude. We said the graph of sine, it has a coefficient, and that coefficient is an amplitude. The graph of cos also has a coefficient, and that coefficient is also an amplitude. Now, when they're looking for the amplitude of f, they're looking for the amplitude of this sine graph now. And we already found the amplitude. We said, what is the amplitude? The amplitude is the cosine, is the coefficient. How much was the coefficient? The coefficient was a, in which it was 2. Easy as that. Next one, 6.4, it says, what is the range of G? Now, when we talk about the range, we're talking about all the y values the graph is ever going to touch. Now, the range, since it's all the y values the graph is going to touch, this graph doesn't have an asymptote. So its lowest point, it's going to touch that point. Its highest point, it's also going to touch that point. Now, let's look at the graph of G. Here is the graph of G. The highest point it's ever going to touch is +1. So here on the right side, I write +1. And the lowest point this graph is ever going to touch is this one. So here at the beginning value, I write -1. Easy as that. Hope we all see that. And then after that, we have the following. Let me remove this. So 6.5. Let me quickly go to 6.5 so that you see it. There. So 6.5 says, for which values of x will the graph of f, when you subtract the graph of g from it, you must get 2. Now, this one probably needs some highlighting. Let me highlight one of them so that you see what we are talking about. So the graph that we are talking about is the graph of f. So let me highlight that one. We are subtracting from the graph of f. So quick graph of f. Let's use this color here. So here's the graph of f. We'll highlight it this way, like that. Guys, I'm using a writing board here. It needs some excellent focus for you to be able to write here. But then here we are. It says, for which values of x will the graph of f, when you subtract the graph of g from it, you must get 2. Now, what we are talking about, we are looking for a point. whereby if I take a y value from this green line, I subtract the y value from this unshaded line, I must get the answer of 2. You all see that? Now, we can try this through trial and error, but the answer to that should be obvious. When we are looking at these two graphs together, as we move, there is a point like here. Let's take this point. What is the y value of f here? The y value here is 0. And what is the y value of g at this point? It's -1. So if I take the y value of this, I subtract the y value of this, do I really get 2? No, because when you say 0 minus -1, that's equals to +1, right? Now, it doesn't suffice. It doesn't get us where we need to go, which means now we need different values. Now, which different values will those ones be? Let's look at this coordinate here. What is the y value for the graph of f here? The y value is 2. And what is the y value for the graph of g here? Here the y value is 0. So this is the graph of f, this is the graph of g. Now, can I subtract this from that? Of course. If I say 2 minus 0, I get 2. So the only point, the only x value whereby I can say when I minus f from g, I get 2, it's only at this x value. What is the x value there? It's this one, 270 degrees. Now, the answer there for 6.5 is 270 degrees. Easy as that. So that's how you would answer this question. And this is just the part 1. So please check the part 2 on the next video.